Dear students, in last class we have studied classification of phenols, nomenclature of phenols, classification based on number of OH group present in the phenols. After that we have studied preparation of phenols by 4 different methods. One is from benzene, then from chlorobenzene, afterwards benzene diazenyl chloride, and then from chemics. So all that preparations are important. Well, after in properties we have studied the boiling point and solubility of phenols. Why the boiling point of phenol is greater than that of the ether and hydrocarbons, and why it is soluble in the water. And then in chemical properties we have studied first property, the reactions involving cleavage of OH bond, not CO bond, OH bond. There we have studied reaction of phenol with sodium, reaction of phenol with NaOH. As we know, phenol is a weak acid, weaker than carbonic acid, and hence it does not displaces carbon dioxide from sodium bicarbonate. Then why phenol behaves as acid, that you are studied based on the resonance structure of phenol and phenoxide ion. The resonance structure shows that phenoxide ion is more stable compared to that of the phenol. Said behave as an acid. Well, afterwards, effect of electron releasing or electron donating group on acidic strength of phenol. So why the crystals are weaker acid than phenol, that you are studied in this part. Then effect of electron withdrawing group on acidic strength. For that you are studied nitrobenzene. We have 3 nitrobenzenes, ortho, meta and para. Among these, which one is strong acid, that also you are studied. Well, after this you have to study again the reaction involving cleavage of OH bond. When in alcohol you have studied this one, it is nothing but esterification or acylation, and also reaction with acid and nitrite. Same thing you have to discuss even in phenol topic also. So here is a reaction called esterification. This also involves cleavage of OH. So phenol undergo esterification with phenol undergo esterification with carboxylic acid. Carboxylic acid to give carboxylic acid in presence of acid, mineral acid, usually you are using HCl, dry HCl to give ester. So example for esterification, carboxylic acid, I am writing benzoic acid. We know the formula for benzoic acid, C double bond O, OH. Then phenol, C6H5 OH, H5 OH. This reaction takes place in presence of H+. It is a reversible reaction. As we know, reversible reaction means reaction proceeding both forward and backward direction. Reaction involves the cleavage of OH bond, the breaking of OH bond of phenol and CO bond of carboxylic acid takes place. Well, you are getting the product. As we know, first we have to name the group attached to the oxygen in ester. The group attached to oxygen is C6H5. This is called phenyl, not benzene. C6H5, remember this point, it's very important. C6H5 is phenyl. Then when it is benzoic acid means ester sending ATE benzoate. So name of this compound is phenyl benzoate. First you have to name the group attached to oxygen of ester, not this group. This group you have to name. Which one? The group attached to oxygen. So it is phenyl benzoate. Plus one more is H2. Phenyl benzoate. Phenyl benzoate. So esters is also formed by acetylation. What is acetylation? Reaction of alcohol or phenol with acetyl chloride. Generally you are using pyridine to absorb HCl formed in the reaction. Here also you are getting ester. Ester is also formed by using acid anhydride like acetic anhydride. So I am writing acetylation. Acetylation. Ester is also formed. Ester is also formed by treating phenol with acetyl chloride. Acetyl chloride in presence of pyridine. We know pyridine is a base which absorbs HCl formed in the reaction. So this reaction is called acetylation. Well, phenol, we know the formula for phenol. We have OH group C6H5 OH plus acetyl chloride CH3 COCl. Well, the reaction takes place in presence of pyridine. It's also reversible in presence of pyridine to give OC double bond OCH3. So I am writing this formula as CH3 C double bond OCl. This is the formula of acetyl chloride. This is phenol. Acetyl chloride, and we know this is Ba or benzoic acid. Benzoic acid. Formula of benzoic acid. Product is ester. As we know, first we have to name the group attached to oxygen. So here which group attached to oxygen? This one. Not this one, it is attached to the carbon. This one is attached to oxygen, so it is phenyl. Then acetic acid means acetate, CH3 C double bond O. Phenyl acetate. Phenyl acetate. I think you are following. One more is, always you have to remember, write all the reactants and products. One more is HCl, otherwise you are losing the marks. So write the all the reactants and products. Sometimes what happens, students used to get about 85, 86 marks, and it goes to the review, second valuation, and at the time of that valuation, each and every step used to see So here, if you are not written HCl, in a hurry you are not written HCl, then you may lose the marks. So avoid this one means you have to write reactants and products, all the reactants and products. Balancing the equation in organic chemistry is not necessary. Balancing ಬೇಕಂತಿಲ್ಲ. ಆದರೆ ರಿಯಾಕ್ಟೆಂಟ್ಸ್ ಪ್ರಾಡಕ್ಟ್ಸ್ ಏನು ಉಂಟಲ್ಲ ಅದು ಸರಿಯಾಗಿ ಬರೀಬೇಕು, ಫಾರ್ಮುಲಾ ಕರೆಕ್ಟ್ ಇರಬೇಕು, ಇಲ್ಲಾಂದರೆ ಮಾರ್ಕ್ಸ್ ಕಟ್ ಆಗುತ್ತೆ. ಯಾವಾಗ ಯೂಸಲಿ ಹೆಚ್ಚಿಗೆ ಮಾರ್ಕ್ಸ್ ಬಂದಾಗ ಕಟ್ ಮಾಡೋ ಚಾನ್ಸಸ್ ಹೆಚ್ಚಿಗೆ ಇರುತ್ತೆ. ಸೊ ಪ್ರೆಸೆಂಟೈಸೇಷನ್ ನೆಕ್ಸ್ಟ್ ester is also formed by treating phenol or alcohol with acid and nitrate in presence of catalyst H2SO4. Ester is also formed by reaction of acid and nitrite with phenol. So example salicylic acid. Salicylic acid react with phenol. Salicylic acid react with acetic anhydride, in presence of few drops of concentrated H2SO4 to give aspirin. We know ester is formed by treating with carboxylic acid, by treating with acid chloride or acetyl chloride. It is called acetylation. This is called general esterification. It is also formed by treating alcohol or phenol with acid and nitrite like acetic anhydride. And here you are using H2SO4 as a dehydrating agent, as a catalyst. Well, the product aspirin is important. So you are using aspirin for heart disease. You are using aspirin to lower the body temperature. There are many applications of aspirin. Now question arises, what about, I have not mentioned phenol in this reaction. So the statement is salicylic acid react with acetic anhydride. Where is phenol? So salicylic acid is nothing but a derivative of phenol. I will write that equation, it will be clear. So it's a derivative of phenol. I am writing here. The formula for salicylic acid is C6H5COOH, then we have OH. This is salicylic acid. It's nothing but a derivative of phenol. One H is replaced by COH. Well, the name of IUPAC name of this compound is 2-hydroxy benzoic acid. 2-hydroxy benzoic acid. Why it's called 2-hydroxy benzoic acid? Because we know this is called benzoic acid, C6H5COH. Then one nitrogen on the ortho position is replaced by OH. It's also called ortho-hydroxy benzoic acid. One nitrogen is replaced by OH. So it becomes C6H4COH OH. Well, you are giving preference to the carbon attached to the COH group. So this is first carbon, this one is second. Well, the name of this compound is 2-hydroxy benzoic acid. And already we have studied the formula of acetic anhydride, CH3 CO, then it's O CO CH3. This is acetic anhydride. Acetic anhydride. This reaction takes place in presence of concentrated H2SO4. 2 drops of concentrated H2SO4 is used. Just it is heated, not to high temperature. The product is, we have COOH. Remember, the COH group is not affected by acetic anhydride. Only the OH group interact. Remember, it involves the reaction involving cleavage of OH bond. That means the side loading is replaced by some other group. So it's a O C double bond O, then it is OCH3, and one more is CH3 COOH. So this is aspirin. We can also in short form OCOCH3. OC double bond CH3. OCOCH3. We can also write this OC double bond OCH3. This is aspirin, important compound of phenol. What's the IUPAC name of this one? Again, IUPAC name of this one is 2-acetoxy. This is acetic acid, acetate, CH3CO, acetoxy. On second carbon, so it is a 2-acetoxy benzoic acid. It's also called 2-acetoxy benzoic acid. Acetoxy benzoic acid. So remember this name also, it's important from the point of examination. Not only from the annual examination, it's important for the competitive examination. Sometimes in the competitive examination, instead of giving the salicylic acid, 2-hydroxybenzoic acid may be given, or ortho-hydroxybenzoic acid may be given. Instead of aspirin, may be asked the product formed in the reaction, may be given some other name. So you must be perfect in this name also, along with the common name. So this is esterification. After esterification, you have to discuss or you have to study electrophilic substitution reaction. Means the substitution of hydrogen of a benzene ring of the phenol by electrophiles. So electrophiles like NO2, electrophiles like this Br, electrophiles like OCH3, COCH3, etc. That is Frederick-Crafts reaction. We have to discuss on this. Well, in electrophilic substitution reaction, you have to remember the resonance structure of phenol. The resonance structure of phenol indicates there is a positive charge on a negative charge on ortho and para position. We don't find the positive charge at meta position. That means in phenol, the OH group is ortho and para directing. You are getting only ortho and para product. This point is you have to remember. It's important and easy. Well, otherwise you have to write the resonance structure and see where you are getting the negative charge, whether on the ortho position, meta position or para position, that you have to see. Simply you can remember ortho and para position. Already you are studied this structure of phenol as well as phenoxide ion. Let us discuss electrophilic substitution reaction. Electrophilic substitution reaction. Electrophilic substitution reaction. In phenol, OH group is ortho and para directing. Therefore, ortho and para substituted products are formed. Ortho and para substituted derivatives of phenol are formed in electrophilic substitution reaction. Electrophilic substitution reaction. So examples. So bromination. Bromination. In bromination we have two reactions. One is by using aqueous bromine and second one is by using carbon disulfide. Just by mixing aqueous bromine, that is bromine water, with phenol, you are getting white precipitate. So it is one of the tests for phenol. You are getting white precipitate of 2,4,6 tribromophenol. So remember it is 2,4,6, not simple tribromophenol. If you write tribromophenol, you may lose the marks because bromine is on the second, fourth and sixth carbon atom of benzene ring. Bromination is also possible by using carbon disulfide or carbon tetrachloride. That is, you are mixing phenol with bromine in carbon disulfide or carbon tetrachloride. There you are getting ortho and para product. So why it is so? This is because already you are studied in aqueous solution, phenol ionizes to produce H plus and phenoxide ion. And phenoxide ion, that is O minus, makes benzene ring more active compared to that of the phenol. It is possible when you are using aqueous bromine. If you are using the bromine in carbon disulfide or carbon tetrachloride, then ionization of phenol do not take place. So product is ortho and para. Bromination. Number 1, phenol undergoes bromination with bromine water, or you may say aqueous bromine, to give 2,4,6 tribromophenol. So product is 2,4,6 tribromophenol, white PPT. So you can use this reaction as a test for phenol because you are getting white PPT. So you can observe it. Question is phenol plus bromine. And to write aqueous or bromine water, the product is 2,4,6 tribromophenol. OH, Br, and Br plus 3HBr. 2, 4, 6 tribromophenols. So mentioning these numbers, this is the first carbon, this one is second, third, fourth, fifth and sixth. Mentioning that number 2, 3, 4, 6 tribromophenols is important. Second one, phenol undergoes bromination in CS2 or CCl4 to give ortho and para bromophenol. Ortho and para bromophenol. So equation means phenol plus Br2 in CS2. CS2 is the medium, carbon disulfide liquid or carbon tetrachloride. The product is ortho and para, because OH group is ortho and para directing. Ortho and para. One more product is HBr. So you are getting ortho and para product. This is orthobromophenols. And this one is parabromophenols. Should be perfect in IPC name also. So this one is 2 bromophenol according to IPC. This one is 4 bromophenol. So after this we have to discuss the nitration. It is similar to that of bromination in aqueous solution, concentrated HNO3 or dilute HNO3, you are getting different products. If concentrated HNO3, you are getting this product, or that is on the second, fourth, and then on the sixth position we have in NO2. If you are using dilute, then it's ortho and para nitrophenol. Start there. So it is 1 phenol undergoes nitration with dilute HNO3 at low temperature. At low temperature 298 Kelvin to give ortho and nitrophenol and paranitrophenol. So it is phenol, then HNO3, so dilute is important, low temperature. So product is orthonitrophenol and paranitrophenol. Orthonitrophenol and paranitrophenol plus so orthonitrophenol, and this one is paranitrophenol. Or it is 2-nitrophenol and this one is 4-nitrophenol. 2-nitrophenol and 4-nitrophenol according to the IUPAC system. And then it's with concentrated HNO3 you are getting 2,4,6-trinitrophenol called picric acid. Second one, phenol react with concentrated HNO3 to give 2,4,6-trinitrophenol called picric acid. Picric acid. 2,4,6-trinitrophenol or picric acid. You are getting yellow color PPT here. Phenol plus HNO3 is concentrated. It's important. Writing the concentrated is important. Product is 2,4,6-trinitrophenol, OH, NO2, NO2 and NO2. 2,4,6-trinitrophenol plus 3H2. 2,4,6-trinitrophenol. So this is about reaction of phenol with the concentrated and with the dilute HNO3. Remember condition. So conditions are important. I will give few more examples.